Hello and welcome to today's lecture on Sumo, the simulation of urban mobility. But in most cases, it is popularly called Sumo, and we know this is a traffic simulation model that is used to have a little bit of a form of realistic view of what a road network would be or whatever design that we intend to put into implementation in a road network. Popularly, we know that Sumo is an open source microscopic traffic simulation software, and it is designed to model and to analyze the movement of vehicles, pedestrians, and other transportation systems in an urban area. That is where the word urban mobility comes into play. And it provides detailed simulation of traffic flow, vehicle interaction, that is, the interaction between vehicles, and transportation infrastructure, making it ideal for urban planning, traffic management, and mobility studies. So there are some key features whenever we are looking into the Sumo. There are some key features we need to take into consideration. And one of the key features is microscopic simulation. That is, it models individual vehicles, their interaction, and traffic behavior at the level of specific road, intersection, and traffic signal. So that is what makes it a microscopic simulation. It comes to the idea of to the smallest of individual vehicles, the details, the properties. Another key feature is multimodal. It supports a variety of transportation modes such as cars, buses, bikes, and pedestrians. So it is not unimodal, it is not bimodal, but it is multimodal in nature. Another key feature we can say about Sumo would definitely be that the scalability. Scalability in sense of it can simulate large networks with thousands of vehicles in complex urban environments. So it's not limited. It has the capacity to manage and simulate large networks with over thousands of vehicles at a time. Then we have the customization, that is, the users can define traffic demands, the road geometrics, signal control, and other factors to tailor simulation to specific real-world scenarios. And the data integration of Sumo can help to integrate real-world data sources like GPS, traces, and traffic counter, things like that. So in a nutshell, it's all about the creating computational models that sees to the analysis of movement of people, vehicles, and goods within an urban environment. And this can be used for planning by urban planners. It can be used by transportation engineers, policymakers, and a lot of other agencies to evaluate the impact on different policies, infrastructural change, and the urban design on traffic flow, congestion, air quality, that is in sense of carbon emission, and the overall mobility within the transportation network. So we know that one of the key approach of simulation is the use of an agent-based modeling. And what do we call an agent-based modeling? That is the use of individual agents that represent entities such as vehicles, pedestrians, or public transportation systems. These agents, the interaction of these agents with one another in an environment based or with a predefined rules and parameters, allowing researchers to study the complex urban dynamics in a virtual environment. And that is still what Sumo is all about. Because we cannot have it done in a real world environment. So using it and still having a visual representation of what we want it to look like in the real world in a virtual environment is still what the idea of Sumo is. Then we have some that we use in Sumo. The first one is what we call the network. We know in under when we're studying this of a network is the nodes and the edges. That is, the nodes and the edges makes up a network. And that means within that node and network there are what we call the lanes. We have the junctions, the traffic lights, and connections between different roads and segments. So it's defined as the physical layout of the urban area that is to be simulated on. So whatever area within that urban setup that is being simulated is what we call the network. For the vehicles, we know there are various entities that move within the simulation of an environment. And all these vehicles, they can be assigned different kind of route, different speed, different behaviors. They move at different pace, different directions. So the vehicles we're talking about here, they are animals in nature and they have different specification, classification, and types of them, which we're still going to be looking at in one of the terminologies used in Sumo. Then we have what we call the route. That is to define the route defines the path that vehicles follows within the network. So that path that is being defined within a road network where vehicles are going to move, or probably for pedestrians or for bicycles, then that is what we call the route. Then we have what we call the hedges. The hedges is also called the links. So it is called the links between intersections in a road network. So like I said also earlier, when we have a road network or a graph or a network, that means it is the relationship between the nodes and the edges. So that means there has to be the coming together of the nodes, which can also be called the vertices, and the edges should be also called the links, in order to be able to create a graph or a network on the road. And like I said, the node is the interaction where edges meet. So that means we can have a node at one point, another node at another ending point. So the distance between the two of them, or what we have between two nodes, is what we call the edges. And we have it's just a path represents an edge on a road network. So that means when we have an edge in a road network, within those edges we have lanes. And in one of our previous lectures, we talked about the different types of lanes. We have the through lane, we have the right turn lane, the left turn lane. So within all these types of lanes or on this road network, all these things are embedded within the edges, or what we call the lanes. Then the vehicle forms of vehicles. And when we're talking about vehicles here, it's in sense of we have cars, we have trucks, we have bicycles, and all these vehicle types also come with different classification properties based on their size, their capacity, the maximum speed, the emission level. The emission level are different. So it is very important that the type of vehicle we are going to be using is going to be also dependent on the size, the capacity, and also the emission level within our study. Then, still under the terms in Sumo, we have the traffic light. I think this one is self-explanatory because the traffic light can be programmed within specific timing and phase to optimize the flow. At the point of intersection, we mostly use the traffic light in order to help us manage the flow of vehicles and pedestrians. Then we have the junction, and this junction represents intersections or points where roads meet in a network. At any point where a road meets within a particular network, that particular is being said to be called a junction. That's a junction. And different types of junction, we have the traffic light control. The priority junctions can also still be modeled in Sumo to simulate various traffic scenarios. So we've already explained what an edge is earlier. So we have what we call the simulation time. When we're still going to be looking into that when we go into simulation itself, like simulating a particular road network or any road network. When we want to the simulation to see how the behavior of the vehicles and traffic flow, you're going to be setting a certain duration in sense of maybe how long you want that simulation to run for, and to be able to observe the behavior of vehicles and the traffic flow and other parameters over a specific period. Sometimes some people can run it within 60 minutes. Some people you can decide to run it maybe within 120 minutes, 90 minutes. So that's that timing that you want to use to study to observe the behavior of the vehicles, the traffic flow, and other parameters is what we call the simulation time. Then we have the traffic flow. The traffic flow talks about the movement of vehicles through the network. That is self-explanatory. There are some parameters, or there are some metrics that are being used in measuring the traffic flow. We have the density of the vehicles, talking about the speed, talking about the congestion level, the travel times. So these are some of the metrics that are used in these are some of the metrics that are used in traffic flow in Sumo. And this talks about how Sumo models lane changing behavior. And that is when vehicles decide to switch lanes or overtake or merge to adapt to changing traffic conditions. Behaviors can be customized based on the driver's behavior model. And this can also be done within the Sumo network. Then we have the traffic. This talks about the volume of vehicles that are entering the network at once. When we're setting up a Sumo using NetEdit or using the OSM, we are going to be required to put in what is our vehicle, what is the volume of the vehicles we want in that particular network or in that simulation in order to study how they interact. So the traffic demand when it is 10 or 50 cannot be the same when it is 400 or 500. So traffic demand profiles can be defined to simulate peak hours, special events or varying level of congestion. There are some times on the road network where the traffic demand is very low, and there are some times where the traffic demand is high. And when it is high, those are the times we call it a peak period. So this is another term you can use in Sumo. So the next aspect we're going to be looking into is the Sumo network editing tools, or some of the applications that are used in Sumo. So in one of the videos I made earlier, Sumo, when you download the Sumo application on your device, it comes with Sumo, it comes with the NetEdit, and it also comes with OpenMap OSM, that is OpenStreetMap wizard. So it comes with those three um, editing tools. So we're going to be looking into the editing tools. So one of it is Bitmap OSM. The OpenStreetMap OSM is like it's a collaborative mapping project that provides freely accessible editing geographical data of the world. It is often used for mapping roads, buildings, and other infrastructure. The data is used by a variety of applications, including navigation, geolocation, services, and a sense of Sumo to generate realistic traffic nets. That gives us a realistic view of the road net, and this provides a real-time view of any form of location within the world. Just from what we can see in the picture, on the slide you can see it shows it shows the area, it shows the network, the road network that we want to have a view of in the world. So we're able to generate scenarios based on the city, based on the country, based on the states we want to develop or we want to edit the road network. And some of the key features in OpenStreetMap is open data. That is, the OSM, it provides freely available high-quality geographical data created by a global community of contributors. So that is one of the key features of the OSM. And also, it includes data for roads, railways, land use, buildings, and more. So that is, there is a form of detailed infrastructure about about the road network. So it doesn't just provide information or data about the road, but it also provides for railways, it provides for the land use, it provides for buildings and many further. Then another feature of the OpenStreetMap is the global coverage. It spans the entire globe. That is in which it is useful for building accurate maps and network models for simulation like Sumo. Then the users can also add custom tags and information to the data, which makes it highly efficient to use. So these are some of the key features we can see in the picture. So furthermore, we also have a bigger view of that here. We can see before, I think this was after one we generated. Let me go back to the previous picture. The previous picture we can see on the right hand side of the screen where we have the Berlin. So the current location we're looking at here based on this picture is Berlin. Then when you search based on the latitude here, then you can go to or use your current location through your GPS location, the current location you have, and to give a detailed road network of your vicinity. Or if you can include any city, state, or country you want to see the road network based on that real-time information. So that can be done here. So when that is done, then we have the cars. Then this shows the true traffic factors and the number of kinds of cars. So develop what do you want to build out from that network? Do you want to be able to identify the trucks, the motorcycles, bicycles, pedestrians, trams, and then trains and the ships? So then it's left for us to decide that with it by without taking the ones we want and the ones we don't. So I was able to try this with the area I grew up in Nigeria, in Lagos, Nigeria. So what it looks like, the area I grew up in my country, Lagos, Nigeria. So this is just a view of it. So the next editing tool is what we call the net edit. And this net edit is a powerful editing tool, very powerful, and it's a graphical tool that is typically used alongside Sumo to edit and create road networks. So this provides a user-friendly interface and design road layouts, including lanes, intersections, and traffic signals, which are then used in Sumo simulation. This provides a ground for us to be able to create whatever lane, whatever design road layout we want to, then running it using the Sumo simulation to see how the interaction is with other elements or parameters. So there are some also this also has some key features that are very important for us to look into. That is graphical network editing. That is, this allows users to be able to create, edit, and visualize road networks, in the positionings of lanes, roads, and intersections. And also, the network created with NetEdit can directly be exported to Sumo for simulation. So when we get to the point where we are actually having examples of being able to draw up a road network. I'll explain more on that. But the first thing when we have is a representation of the kind of road network we want, it is usually done on NetEdit. So after when that is done, it is now exported to Sumo, where you run the simulation to see how the real time or visualization of how the parameters, the vehicles, and every other factors they interact with one another for decision making. So that is interactive. The interface is interactive and allows users to interact with the network visually, making it easier to build and modify urban road structures. So that is another key feature of NetEdit has been a powerful tool used in Sumo. So another important part of the key features of NetEdit is that the users can define attributes such as the speed limit, such as the road capacity, the signal timing. You have the ability to be able to define it the way that suits what network that you are trying to develop. So you can decide to either if the the seconds or the seconds for the green light is just 3 seconds. You can decide to move it to 1 or 5 seconds. You can design it based on any way you want. So this interface or this powerful editing tool of NetEdit enable us to be able to carry this out. So in summary, looking at the three editing tools that is Sumo itself, the OSM OpenStreet, the OSM, and also the NetEdit. Sumo is a powerful tool for simulating urban mobility. NetEdit is a useful editing or a useful editing tool for designing the network that can be used in Sumo. And OSM provides the map base and infrastructure data that makes this simulation more realistic and applicable to real world scenarios. So this is just the difference between the three editing tools we have under Sumo. This is a pictorial. This is just a picture of what the net edit looks like, the interface of the net edit. And this, we have the file, the edit, the processing, the network itself. Explain more under this. So, but this is just what the page of the net edit looks like, editing tool looks like. And at this point, the difference between this first picture and the second picture provides a grid to work with. So it provides a grid, but the first one doesn't have a grid. So these are still some of the terms we use in net edit. Then we can see here, this is what we call the nodes. When we want to draw a network, or we have the nodes and the edges, the combination of the nodes and the edges here at this point. Then you can see now at this point, this is the node. So when you're starting, it has the node, which is have the link, or what we call the edges. Then we also have the node. And this can also be named under the net edit. You can decide to name it, maybe give it the ID name for a particular, we just give it a name. And this talks about the centimeters of, or the details of that scene itself, or that graph. So like some of the key features and functionalities of NetEdit being the graphical interface and also the network elements, in terms of being able to define networks such as the junctions, lane, edges, connections, traffic lights. So we also have the lane configuration, being able to determine the speed limit, the lane type. Is it going to be a 4-lane? Will it be a 2-lane? Will it be a 3-lane? If it is going to be a 4-lane, are we going to be having two true lanes, the one right turn and the left turn? So it depends. So the lane configuration, all these things are also done under the net edit. And also the multiple lanes for each road segment and specified lane changing rules for vehicles. That is the lane configuration. Also, under this, you can determine whether you want to give priority rules or the right of way rules within the network, or the net, or the type of traffic signal that you want to develop in that particular road network. So we also have the import and the export. Like I explained earlier, whatever that is done under NetEdit are being exported to Sumo in order to run the simulation. And the same thing also goes for the OpenStreetMap, also OSM. So some of these things, some of these files can be saved. It can also be imported in for editing. It can be imported and it can also be exported. Then the validation tools. These tools help to check the consistency and of the network layout in order to be able to identify or resolve errors or conflicts in the network design before running simulation. At the point where we're running, when we are setting up our road network or building a road network using NetEdit, you can see at the lower part of the screen where it shows where there is an error within the layout that needs to be corrected or taken into consideration. But when we're going to be able to give a better explanation of that, then integration, that is the integration such as the Sumo GUI for simulation, visualization, and Jota for route generation. So the users can easily transfer network data created in NetEdit to other Sumo components for running simulations. I think part of what I also explained earlier, that after when the editing has been done using NetEdit or using the OSM, the OpenStreetMap, then it can be exported to Sumo GUI in order to have a better simulation visualization in the other editing tools. So this is an example of a road network. So we're still going to be constructing something like this in one of our videos. So I hope you can stay tuned to be able to go. We are going to start step by step with the creation from the point of one node to another node, creating a link to be able to create a road network, something similar to this. So I will see you in the next video.